Hello, and thank you for joining this live webinar presented by the Cisco Learning Network. This webinar will be recorded and made available on the Cisco Learning Network, and information on how to access the recording will be emailed to you following the live session. Please allow up to 5 business days for the full recording to be made available. Thank you very much and enjoy the presentation. Hello, and thank you for joining this live webinar presented by the Cisco Learning Network. This webinar will be recorded and made available on the Cisco Learning Network, and information on how to access the recording will be emailed to you following the live session. Please allow up to 5 business days for the full recording to be made available. Thank you very much and enjoy the presentation. Hello, and thank you for joining this live webinar presented by the Cisco Learning Network. This webinar will be recorded and made available on the Cisco Learning Network, and information on how to access the recording will be emailed to you following the live session. Please allow up to 5 business days for the full recording to be made available. Thank you very much and enjoy the presentation. Hello, and thank you for joining this live webinar presented by the Cisco Learning Network. This webinar will be recorded and made available on the Cisco Learning Network, and information on how to access the recording will be emailed to you following the live session. Please allow up to 5 business days for the full recording to be made available. Thank you very much and enjoy the presentation. Hello, and thank you for joining this live webinar presented by the Cisco Learning Network. This webinar will be recorded and made available on the Cisco Learning Network, and information on how to access the recording will be emailed to you following the live session. Please allow up to 5 business days for the full recording to be made available. Thank you very much and enjoy the presentation. Hello, and thank you for joining this live webinar presented by the Cisco Learning Network. This webinar will be recorded and made available on the Cisco Learning Network, and information on how to access the recording will be emailed to you following the live.
This meeting is being recorded.
Hello to everybody and welcome to today's webinar. We appreciate you taking the time out of your day to join us. My name is Tanner Swift and I'll be your moderator for this session. I'm pleased to introduce today's speaker, Gary Martin, but before I hand the mic over to our presenter, I do have a few housekeeping items to cover about this presentation. Today's webinar will be recorded and made available on demand after the live session. We will provide you with some of those details near the end. Also, we'd love to hear from you during today's presentation. During the session, if you are on WebEx with us and have any questions for Gary, please submit those through the Q&A panel and we will answer them during the Q&A portion of our session. If you experience any audio issues during today's session, please use the call-in number displayed on the chat screen. I will post that once again momentarily. So without further ado, I'd like to kick things off by welcoming Gary. Gary, right over to you.
Hey, thanks, Tanner. So as Tanner mentioned, my name is Gary Martin, and I will be presenting today on modernizing cloud-native applications using Cisco Cloud Observability. A little bit about my background before we get started. I've been working in the APM realm for about 10 years now, and I've done everything from setting up applications on the development side to working on the operations side. For about the last 6 years, I've worked with AppDynamics, and I've been at Cisco for about 3.5. So let's go ahead and get started. Today, we're going to cover a brief introduction about why cloud-native applications, you need a specialized tool to handle them in this modern development world. We're going to look at an overview of OpenTelemetry, how we integrate with cloud services. We're going to look at Kubernetes and app monitoring, alerting, and then we'll conclude with the demo. So let's go ahead and get started. You know, every product starts off with a story, and Cisco Cloud Observability started off with this story. Modern applications have changed the way that we think about development and the way we think about monitoring, because the complexity has increased exponentially. Look at this example here. Here's an application, and this is a very simplified view where we have 4 microservices: a Java microservice, a Python microservice, a C++ microservice, and a Go microservice. They're all different languages, have different application functionality, and we can see that the Java microservice is running in the Azure cloud, while the Go microservice is running in the AWS cloud. Now, if I'm a service reliability engineer or an operations person, and I'm responsible for trying to troubleshoot something, I first have to have some context. Where does this microservice reside? Then I have to have some kind of tool that allows me to see communication between these microservices that may be in different languages. All of this adds complexity. And I can tell you, most modern applications don't just have 4 microservices. One customer we're dealing with right now has a large customer portal dealing with hundreds of microservices in different languages, housed in Azure and then on-prem. And they have multiple different service reliability engineers and operations folks trying to make sure that those microservices provide the appropriate availability and performance for their customers. This group needed a tool that could give them that kind of visibility. That's where the Cisco Cloud Observability comes into play. Before I go into how Cisco Cloud Observability really provides benefits in cloud native architectures for you to get the visibility you need. I'd like to give you a little bit of background on OpenTelemetry, because OpenTelemetry is what this platform is built upon. Like, it's developed to use OpenTelemetry. Not everyone has heard of OpenTelemetry, but it's been around for about, I don't know, 4 years now, maybe 5 years, and it's going to be becoming more and more prevalent in the industry. So what is OpenTelemetry? OpenTelemetry is a vendor-neutral standard that collects telemetry data for applications, their supporting infrastructure, and services. And it came from a merger of OpenCensus and OpenTracing, which is a Google project. And the reason OpenTelemetry came about is because a bunch of folks got together in 2 separate projects, and they said, hey, we have the exact scenario I showed earlier: microservices, different languages, different environments. We need a way that we can easily troubleshoot, easily understand performance, quickly troubleshoot issues. And there's nothing out there that really does a great job with that gives us the flexibility we need. So 2 separate projects started, and then they merged into what is now the OpenTelemetry open source project. So why should you even care about OpenTelemetry? Right? Why are you even telling me about this, Gary? What's important about it? Well, OpenTelemetry is being contributed to by every major APM vendor. And the last I checked, several months ago, Cisco was a leading contributor to this community. But every major APM vendor is contributing to it. In fact, it's the second highest contributed project next to Kubernetes. And I think most of us have heard about Kubernetes before and how that's taking off. There's literally not a major organization that I'm involved in that does not have at least one Kubernetes implementation, if not many. OpenTelemetry is an industry disruptor. It's changing how we look at monitoring and the things we can do with monitoring. And it solves the complex problems caused by cloud-native applications. And the reason we're starting off with OpenTelemetry is you can see where the industry is headed, how important it is. Everybody's seeing the writing on the wall, and that's what Cisco Cloud Observability is built upon: OpenTelemetry. Here's a little bit of how it works. And I give you this screen because it's going to give you some understanding of how we do things with Cisco Cloud Observability. At the application level, OpenTelemetry has an API and an SDK. And this API or SDK can get rolled up into agents. And these agents, what they do is they extract the different data, transform it into OpenTelemetry, and send it to a collector. This collector is outside of your application. And you can do fancy things with this collector by filtering data, like batching data. I can speed up or slow down the traces I'm collecting. And I can do this all outside my application. So I can, as an ops person, I can make these changes. I'm trying to troubleshoot something. I need to collect more traces. I can go in my collector and collect more traces. There's some kind of data that's sensitive. Credit card information. I want to make sure there's no leakage to a cloud environment, a public cloud environment. I can add a data filter to make sure that that data gets filtered out in case it gets missed somehow. And then after that collector level, it gets sent to a backend like Cisco Cloud Observability, where all the magic happens that I'm going to show you, where we provide a detailed overview of the health of your application, as well as all the tools you need to troubleshoot any issues. So now that we have an understanding of what this product is built upon, let's talk about some of the fancy things we can do with it. Let's start with integration with cloud services. I'd like to show you this diagram here as we start getting into this topic. It's the Cisco Cloud Observability data flow from like a high level. You can notice here that we have Kubernetes environment. We're collecting information. We're collecting data from applications and infrastructure, and we're collecting data from cloud services. And then all of that data goes down to our FSO platform. And then Cisco Cloud Observability uses that FSO platform to pull that data up and provide the observability you're looking for. The concept of this FSO platform is very powerful because things that emit OpenTelemetry can be collected by this platform and then extracted using Cisco Cloud Observability. So one of the things that you saw in that prior slide was the ability to collect information from cloud services, right? So what are we talking about when we say cloud services? We're talking about these public cloud services like CloudWatch from AWS, like Azure Monitor from Microsoft Azure, like from GCP, the services that come from the Google Cloud Platform. And this is a very powerful concept because these vendors have very specialized tools at times that are native to their platform that allows them to monitor different aspects of it. So we have the ability to ingest data using a wizard that makes a simple connection to any one of these three services. Once this connection is made, I have the ability to determine which services I want to use and which services I don't want to use. And then I can ingest and correlate those metrics. At any time, I can go in and say, I want to look at this service. For example, I want to look at RDS with CloudWatch. I can monitor that service, and at some point I say, you know what? I don't want to have that ingestion at this point in time. It's not as important. I don't want to incur the cost. I can uncheck it, and I don't have to import that service anymore, right? So we support many AWS, Azure, and GCP services, and we're consistently adding more. I have a sampling of certain Azure services, and this is a very small sample. Same for AWS. I could easily take a couple slides and just fill in everything that we handle from those three cloud environments. But for example's sake, here are a couple of samples from AWS and Azure. So once I have my cloud connections, right? It's kind of like my step one with Cisco Cloud Observability. I'm making my cloud connections so I can import those metrics that I really care about and use them to quickly troubleshoot, right? The next thing I want to do is I wanted to start deploying monitoring to my different environments, such as Kubernetes and my different application services. From a Kubernetes standpoint, there's a lot of functionality that it gets provided. Full melt is garnered from this particular when we deploy our OpenTelemetry operators and collectors to our Kubernetes environment. So we're able to see the native clusters, hosts, namespaces, and workloads. We get that melt, that metric, events, logs, and traces for that Kubernetes environment. So if I have an issue with Kubernetes, I can drill into that issue. I can see the logs. I can see the events. I can see the metrics associated with any particular issue. I get quick and easy widgets that provide me health and status and timelines, so I can see the volume over time of my different events. I can see the health, and I can quickly drill into those different widgets in order to get information to help me troubleshoot. We make deploying monitoring to infrastructure very easy. The simplified deployment process for Kubernetes is as such. We allow you to go to Cisco Cloud Observability. There's a configure section, and we allow you to download a file that contains all the endpoints for your Cisco Cloud Observability tenant, and it includes all the different configuration options you may want to use. These options are not something you have to use, but they're all in one file. We then provide you with Helm charts that allow for quick and automated deployments. When I work with our customers to show how this deployment of monitoring works for a Kubernetes environment, I can throw up monitoring for like EKS or AKS in about 5 minutes. I simply grab my configuration files from my config wizard, add my Helm repo, add a namespace to my Kubernetes environment, and then I deploy my files, and those Helm charts perform all the magic. A very quick process, easily automated, perfect for modern day applications. So we've looked at 2 steps here. We've started off with our cloud monitoring. We connected to our different cloud environments. I'm pulling in, if I'm connected to AWS, I'm pulling in the specific CloudWatch services I'm using. And now I have also deployed my monitoring for my Kubernetes environments. Let's just say, for simplicity's sake, EKS. So now I have layers. I have my cloud services. I got my Kubernetes infrastructure. What's left? My application monitoring. Cisco Cloud Observability allows for correlated view of services for insight into performance and availability. For those that you are familiar with our commercial SaaS product, we have a flow map that is readily apparent on the home screen. We have the same kind of concept within Cisco Cloud Observability. I can see how my microservices interact with one another. I can see if those microservices are having problems or not by our traffic light signals. Green is good, yellow warning, red is some kind of critical error. For each of these microservices that I'm monitoring, much like Kubernetes, I get the melt data in one view. I get metrics, events, logs, and traces. And I can use all of those to quickly troubleshoot a problem. We'll see this in our demo. But for example, if one of my microservices suddenly goes red, I can click on that microservice. I can then see all related traces. I can see the exact span that's having the issue and get an idea of what's causing it. And if I need additional information, I click on a simple button that jumps me to my logs that are directly correlated to that particular span. Now, along with this melt data, we provide health status and timelines that provide context for easy troubleshooting. So I can see over time how my microservice is performing, and if any health rules trigger, I can have that information. When I drill down into an individual service, right, I'm able to see what that service is working with. I can even go to a specific, I can switch to look at spans for a particular trace for that microservice. And I can follow that path to see which spans are having problems. I can see a contextual view. If you look on the left side of that screenshot where it says business transactions, service instances, and cluster, I have the ability to have context for where that service is running in. That's a very important concept. Imagine if you're a service reliability engineer and you're supporting many applications. All of a sudden, you receive some kind of notice that there is a problem with this particular microservice. Now, you support many microservices. You're able here to jump, and at a glance, you can see what cluster this microservice is running in, what namespace it's running in, what pod it's running in. You can also see if that pod is having problems, or that cluster is having problems, or that namespace is having problems. That correlation is immensely valuable to somebody who's trying to quickly troubleshoot something in a Kubernetes environment and may have to deal with many microservices. And even if I don't have to deal with many microservices, the ability to quickly see where that microservice is living at that moment in time, where it's having a problem, easily allows me to understand if it's an infrastructure issue, if it's an application issue, and drill down and get to root cause. When it comes to application monitoring, another powerful feature that's within Cisco Cloud Observability is business transactions. A business transaction is the ability to see something end to end. It can be a critical service, it can be like a feature, but something that you want to see end to end. And we call it a business transaction because it's looking at it from the customer perspective. For example, if I'm logging into something, if logging into an application, that login or going end to end for a user can go through many different steps. But if I'm trying to troubleshoot at a high level, I want to understand if my login business transaction is having problems. That's the macro view. And then be able to drill down in my traces. That's the micro view to get to root cause. Business transactions I think of as fancy filters that allow us to find the needle in the haystack. It kind of bubbles things up from these are the important things that a user does within my application. And I can easily see if the user is having problems with any of those and then drill down and get to the root cause. One of the things that's pretty a neat feature within Cisco Cloud Observability is you have the ability to favorite your most desired business transactions. Certain business transactions can be more important than others. If I have a business and transaction called login, that is probably more important than a business transaction, for not to necessarily do it for this, but for the help screen, right? So I can favorite the ones that are most critical. And when combined with anomaly detection, which we'll look at in a little bit, I can quickly drill down and get to the root cause. Now, another powerful feature within Cisco Cloud Observability on the application side is the ability to mask sensitive data. So why is this such a big deal? Well, a lot of these cloud native applications are running in these public clouds like AWS, like Azure, like GCP. And even if it's, government cloud, for example, there are certain compliance issues that can be violated if certain data gets up into a cloud. These can be internal regulations or external regulations. I used to work for a large aviation company or aerospace company, and if they dealt with the defense side also, and if even a name of a certain plane ended up in that public cloud environment, the government could fine them millions of dollars. Or we all have heard the horror stories about leakage where sensitive PII gets out, that private information like social security number or credit card information. Well, there is the ability to mask that data. And as I showed you before, at that collector level, it can be added at any time. And you have the ability to mask that data in order to ensure that that leakage doesn't happen, right? So that allows you to comply with, your data protection policies, helps with effective auditing and investigation, right? And this could be internal or external. Right? And all of this is done in the processing pipeline before being stored, right? So that's an important aspect to remember also. Let's talk about alerting now. Very important concept. So with alerting, we have the ability to have health rule rollups. Well, what's a health rule rollup? This is a feature that is really important when it comes to cloud environments, because we have situations where, I don't necessarily need all my pods within my Kubernetes environment to be healthy for a particular workload. Sometimes I only need, if 50% of my pods are running, I'm happy. If it gets worse than that, right? Maybe I do something where I, send an alert. Sometimes if so many pods are unhealthy, maybe I want it to roll up and say my cluster is unhealthy. So this gives me the ability to have these roll-up rules to say, hey, I have so many pods that aren't working, or my workload is not healthy. Therefore, my namespace is not healthy. And if my namespace is not healthy, my cluster is not healthy. So I can have these layers based on my different, requirements to show what is healthy and what is not healthy in these cloud environments. Because most modern cloud environments aren't like a single server like in the old days. You got all these containers running that support this service. Not all containers necessarily have to be healthy for an application to be considered healthy, for a workload to be considered healthy. Health rules also have the ability, right? With health rules, we can also link health rules to third-party applications, such as ServiceNow or Jira. One of the most common workflows we encounter is I'm going to have a health rule. When that health rule triggers, I want to drop a ticket using something like ServiceNow, or maybe something like PagerDuty, then also automatically calls whoever's on call. And these health rules allow us we can write custom health rules that use formulas that help us to eliminate noise. Besides health rules, which health rules are something that we set up based on metrics. Anomaly detection is based on AI. Anomaly detection is a way for Cisco Cloud Observability to capture things by looking at anomalies within your application infrastructure and alerts you before something happens. I've actually seen some really good examples of this. I was working with a customer, and literally we saw anomaly detection trigger, and they this was a non-production environment. We were testing some things out, and literally 5 minutes later, the environment crashed. The anomaly detection, had it been a production environment, would have given that team enough time to go in and address the issue before there was any production crash. So anomaly detection can be used for business transactions and infrastructure components. You have the ability with anomaly detection to control alert noise by setting different because there's different sensitivity settings. And we'll look at this in the demo also. And we're continuing to build out this feature, but we have the ability to detect memory, CPU, disk, and network issues automatically for AWS EC2. So that is a service outside, right? That's run by AWS. And we're looking to add additional capabilities within anomaly detection for other services in the future. So let's now go ahead and jump to a demo, and I'll start walking you through how this product works and kind of go into detail about some of the slides that I covered so you get a really good grasp of how this product works. So I'm going to share my screen now. And what you're seeing is Cisco Cloud Observability's home screen. This home screen, what it does is it shows you everything that is currently on your tenant. In the past, sometimes we've called this single pane of glass. So what this allows me to do at a glance is to see, hey, here are all my Kubernetes clusters. Here are all my services. And this can be very helpful to me if I have that scenario where I got clusters running in Kubernetes clusters running in AWS, Kubernetes clusters running in Azure, maybe I have some Kubernetes clusters running on OpenShift on-prem. I have the ability to see the health of all my clusters at once. You'll notice also that the next thing is that we have that color scheme that I mentioned. The traffic signal. Green is healthy, yellow warning, red critical. This color scheme is based upon the health rules that you define or the anomaly detection for your application. If it's gray, that means that there is currently no health rule associated with it. This home screen categorizes my different entities into major categories: application performance monitoring, Kubernetes, compute, containers, etc. Right? And I have the ability to click on either looking at all the services or click here on any of these circles and just see the circles that have a green status, a yellow status, a red status, or a gray status for that particular entity. So let's go look at our services here. Say I'm trying to get more information on my e-commerce Blue service. I have the ability to click on that service. And at a glance, I get this correlation, which is a very powerful feature. I can see how many service instances, which is the equivalent of how many containers are running this service. Are they healthy? Are they unhealthy? What cluster is it running in? What namespace? What workload? What pod? I can click on any of these and automatically change the context. So now I'm looking at my service instances. This, at a glance, can help me troubleshoot issues because I can see, is my cluster unhealthy? Oh, my services, all my service instances are unhealthy, but my cluster is unhealthy. Probably an infrastructure issue. Let me drill down into my cluster. Let me use that melt data to try to troubleshoot the problem. Back to my services here. I have the ability to see on this flow map what this particular service communicates with. I can see all my health rule violations at a glance and the time that they occurred. There's a costing aspect that is an additional feature we're not going to cover in this demonstration. But I have my service endpoints, I have my metrics, right? And I can drill into my logs. On the left hand or the right hand side of my screen, I also have some important metadata. Here are my golden signals, average response time, calls per minute, errors per minute. I can look at it at a glance. If I want to understand what anomaly detection is set up for this particular service, or what health rules are associated with this particular service, I simply click here and I get a listing of all the health rules that are currently defined for that, and I can easily make a new one. When it comes to troubleshooting, I have the ability to go to related traces for this service. And I can sort by duration or any of these columns. If I'm having errors, I have the ability to drill in, see my particular trace, and I have the ability to scroll down and see the spans in that trace and where those errors are beginning. If I want to switch views, this is a service view right now, microservice, right? Service to service. But perhaps I want to see from a span view, what spans are causing the issue. I have the ability to switch here to spans. Now I can see, hey, here's where the error is originating. Here's what it affects. What is really nice too about how we set up the ability to use Melt to troubleshoot is I can click on a particular span. Now I get the metadata for this particular span, and I get the related logs for this span. What is nice about this is we're not talking about grabbing logs for just a time period. We're talking about correlating, hey, this is a span, this is the logs that got produced. So I can quickly get dealt information about for my trace, hey, I'm seeing these problems. Maybe I don't have enough information to fully understand what's going on. I need to drill into the logs. And now I see unable to acquire JDBC connection, and this is the reason. If I click on a log entry, now I'm even given the metadata for that particular log entry. I can see, hey, here's the host ID, host name, all of this important information that's associated with this log entry. So I even know where this log entry got generated from a cluster perspective. And perhaps I don't have enough logs. I want to see, hey, you know what? Let me get more logs that surround that entry. Because we're not doing time, we're doing correlation. So maybe I want to get more logs around that workload, that pod, or that container. So you can see the power of how we're able to correlate information, how you can use Melt to quickly troubleshoot issues. Now that's from the microservice APM perspective. But what if I'm a Kubernetes administrator? I have the ability here to drill down in my cluster and let's go back here. Let's go. Let's jump environments here. It's my demo environment. jump into my cluster. So now I'm a Kubernetes administrator. I get a Kubernetes error. Perhaps my cluster is having issues. I want to know what applications are affected by that. I get that correlation. Here are all the services running on that particular cluster. I'm able then to, from a different persona, this same kind of correlation helps me help other teams understand what's going on. Oh, here's who I need to reach out to and let them know, hey, I'm working to address this issue. This Kubernetes cluster is having some kind of sizing issue. I click on pods, for example here. Now I'm looking at it from a pod perspective. Where is this pod running? Click on different pods, and I can get the metadata for that particular pod. What's the CPU? What's the limit? What's memory? Where's the host, etc. So what I want you to take from this, I'm going to jump back to this tenant here. What I want you to take from this is that this correlation is powerful. And it's really unique to Cisco Cloud Observability, our ability to jump around within a Kubernetes environment and give you context. Now, we talked about a couple things at the start, like this cloud connections. If I go under configure and I go to cloud connections, here's where I can set up my particular connection to my cloud environment. And I have the ability to determine what services I want to collect. I also have the ability to come in here, as I mentioned, setting up Kubernetes and APM. And I can have a wizard that produces a config file that I can then add a Helm repo. You might use my Helm charts that utilize that config file for my deployment, quick deployments that can easily be automated. And the last thing that I wanted to, well, two more things I want to show you here. I'd like to show you here anomaly detection. As I mentioned, anomaly detection and the ability to handle application performance monitoring. So here are the different components that we can do anomaly detection against. For infrastructure, we have these right now, and it's going to continue to expand. And then for Kubernetes, we have cluster namespace, pod, and workload. And I have the ability to set the sensitivity. Perhaps it's a very critical environment and it needs to be very sensitive. Or perhaps I'm trying to do some testing and I want to set it really sensitive because I want to make sure I capture any defects before it comes out. I have the ability to set my sensitivity. So very powerful feature. Anomaly detection, purely AI driven. I have it on the APM side, infrastructure, and Kubernetes. And of course, we have health rules, right? You have the ability to select the health rule, how you want to roll that health rule up, and I can define those conditions. The last thing I want to show you before we open this up for questions, because I want to make sure I can allow plenty of time for this, is I want to show you that one of the great things about Cisco Cloud Observability is that it's built on the FSO platform. And this platform allows for Cisco to capture data that's being transmitted from many different OTel sources. Right? And if I go out here under Explore and go to Schema Browser, I actually get a view of all the different entities that I'm capturing and that are on this platform, that I'm querying that platform to get this data to populate this. So why is this a powerful concept? Because perhaps I want to add a category, right? Or maybe I want to add a category of a device or whatever it is. I can transmit that data to the FSO platform, and then Cisco Cloud Observability can extract that information, and then it can be used, right, and monitored. So I'm going to stop sharing now, and I'm going to jump back into our key points to remember. So some of the things that are important to remember. The Cisco Cloud Observability provides monitoring of cloud-native applications and infrastructure regardless of the complexity. More and more, these environments are going to get more complex. These public clouds specialize in certain things. Some clouds, specialize. A lot of folks that I know go to GCP, the Google Cloud, for analytics. AWS tends to be more feature-rich than these other two cloud environments. Azure, many times, is a cost less, and so companies like going to Azure for different reasons. So your microservices that support a particular application can run in many different environments. You need a way to have that observability, that you can easily understand what is going on, where that service is located, and get that melt, that metrics, events, logs, and traces to quickly troubleshoot. That Cisco Cloud, another point to remember is Cisco Cloud Observability rests on the FSO platform. Right? This is an important concept because you're going to see more and more coming out from Cisco about the power of this concept. That it's a platform that we ride upon, that Cisco Cloud Observability rides upon, that's able to pull this data from. And this platform allows for a collection of much data, and then that data to be mined in different views. Cisco Cloud Observability is true observability. It's true application and infrastructure observability. It provides metrics, events, logs, and traces for quick troubleshooting. And one of the great features that we have, and one that's helped me many times when working with customers, the correlation of application and infrastructure in Kubernetes environments facilitates quick troubleshooting. I can quickly see my microservice is running in this pod, in this namespace, in this cluster. So now we're going to go into the question portion of our presentation. So to raise your hand to handle any questions, or preferably you put it in chat, you can go to the Q&A panel, select all panelists, and then in the drop-down list, add your question and submit it. So I appreciate your time and look forward to answering any of your questions. And so I'm going to turn it back over to Tanner.
Appreciate it, Gary. Thank you so much. We will go ahead and take some questions here. Just as a reminder, as Gary mentioned, please use that Q&A panel if you do have some questions for Gary. We will answer those now. First question here from Ron. Gary, what relationship is there between CCO and App Dynamics?
That's a very good question. So just to give a little context for everybody on the call, Cisco Cloud Observability is one product, and then we also have something called App Dynamics Commercial SaaS. So the difference between the two is the commercial SaaS product has the ability to monitor native cloud implementations. but it does not provide the necessary, the same degree of insight, observability, like that melt. And it doesn't provide it in a contextual view. What we're seeing in the industry is typically you have two different types of teams in an organization. You have the teams that handle like your data center applications. Maybe they're delving into the EC2, Azure, VM world. And then you have your teams that deal with, we're putting things in public clouds. They're all microservices. Everything is automated, and it can reside in a bunch of different environments. Cisco Cloud Observability is made for that, for a big part for that use case. Like these applications, modern applications running in these environments, Kubernetes environments, and we give you full melts, that full observability. So that's the difference, I would say, is with Cisco Cloud Observability, we give you that melt, and we give you in a way that's easy to troubleshoot, and it's for these modern cloud native applications. While commercial SaaS can handle part of that, usually the sweet spot for that product deals with data center applications and maybe some EC2 Azure VM instances. And we are, as a company, looking to add some deep links to help you jump from one product to the other in the future. So stay tuned for that.
Perfect. Thank you so much. Let's get to a few other questions here. Can I see what services are running in my Kubernetes cluster?
Yes, absolutely. You have the ability, if you go to that correlation allows, if I go to Kubernetes and I click on cluster, I will have a view that tells me all my services, my service instances, my pods, my namespace, my workloads, etc. And so from that Kubernetes view, I can click on services, jump and see all my services. So that's that power of the correlation. I'm a Kubernetes administrator. This is very common with our customers, especially if you see them running OpenShift. You have two separate teams. I support a Kubernetes environment. I give access to my apps. But as a Kubernetes administrator, it could be hard for me to understand what services are running where. Now it's easy. I click on Kubernetes, click on my cluster. I'm able to quickly see all my services, and that gives me the ability to understand the impact of what's going on in my cluster, as well as potentially notify, teams I'm working on this.
Perfect. Thank you. Can I monitor non-Kubernetes infrastructure like EC2 and Azure Monitor?
Yep. Good question. So absolutely, we have the ability to deploy you can handle this in two ways. You could use either the cloud connection and use like CloudWatch or Azure Monitor to collect metrics for like EC2 instances or Azure VMs. Or you have the option to actually deploy the OpenTelemetry infrastructure agent to those, and then that data will be inputted that way. What is the difference between the two? You get more insight with the agent, gives you more details than just using the cloud connection. So good question.
Perfect. Let's get to one more question here before we wrap up. Can I see logs for multiple applications?
Absolutely. I didn't get to show this in the demonstration, but I have a section here called Explore in the tenant. And in this Explore section in the tenant, there's a category called logs, category called traces, category called spans, that browser scheme I told you, and then there's the ability to query different information. Under that section where it says logs, traces, and spans, I have the ability to see all logs, all traces, and all spans that are collected by that tenant. Now, why would I want to see all logs for a particular tenant? Well, if I'm a service reliability engineer and I'm supporting a particular microservice, multiple microservices, maybe I want to check and see if this particular error is affecting other microservices. So I can quickly do a search and search for that particular error within all the logs on that tenant.
Perfect. Thanks so much, Gary. If there is anything else you would like to cover here before we wrap up, and I provide a few housekeeping items for attendees, is there anything else that you want to mention here before we close it out?
Other than that, this direction that that we're headed at is a really powerful concept. The ability to have an FSO platform to collect data from multiple sources, even outside APM, but then have a tool to mine that data and give you the observability. It just opens up so many possibilities and allows you to have data in the context that is really meaningful for you to get answers quickly. So I appreciate the time.
Really appreciate it, Gary. Thank you once again, and want to thank our whole team for bringing your knowledge to the Cisco community today and today's session. If you do have a question for Gary, we will keep that Q&A window open for a couple more moments. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. I'll place a link in the chat screen here. It usually takes about 5 business days for today's session to be uploaded to our learning plan. However, the live stream on YouTube will be available for playback at any time. You can also follow up with any further questions on our post-webinar discussion thread. That is on the Cisco Learning Network. I also put a link to that in the chat screen for you as well. Your feedback is important, and at this time, you'll be directed to a post-webinar survey. Please take the time to participate in that. Helps us plan out some future sessions. Once again, we thank everybody for joining us today. We will see you next time on the Cisco Learning Network.